Okay, this is how you solve number 22, and I did it a little differently from the way my math lab did it, but you still get the same answers regardless of that. So, first thing is the hint that says solve the demand equation for P and use R of Q equals Q times P. That actually is going to come up a lot, so you're going to want to remember that. So to do that, we have that Q is equal to 7,000 minus 100P. And to solve that for P, the first thing you want to do is subtract 7,000 from Q. Actually from both sides, but it disappears on the right-hand side. And that's equal to negative 100 times P. And the way that the book did it after that was they chose to say that P was equal to Q over negative 100, or excuse me, Q minus 7,000 over negative 100 was the proper solution, but that actually gets really awkward when you're multiplying. So what I chose to do was to split that up. And Q divided by negative 100 is negative 0.01 Q. And then negative 7,000 divided by negative 100 gives you positive 70. And then you multiply P times Q. Then basically you're going to multiply this quantity by Q. And that's going to give you negative 0.01 Q squared plus 70Q. So once you've done that, then you need to take the derivative, R prime of Q. And you can see where if you were dealing with this, that the derivative could get a lot uglier than what I've got. The derivative is actually 2 times negative 0.01 is negative 0.02 times Q to the 2 minus 1 is 1. And then the derivative of 70Q is just 70. So now that you've got the derivative, then it's fairly easy to plug in and find R prime of 1,500. Which turns out to be 40. And then R prime of 3,500, which turns out to be 0. And then R prime of 6,000, which turns out to be negative 50. So hopefully that'll take care of that one. Number 23 is similar, but you don't have to do the solution first. Number 23, you already have an expression for P in terms of Q. So again, R of Q is going to be equal to Q times P. And again, I took kind of a different approach from what my math lab approach was, but I get the same answer. If you multiply Q times 18,000 over Q squared, and I'm just distributing the Q is what I'm doing here, plus Q times 1,500 100, then R of Q turns out to be 18,000 over Q plus 1,500 Q. And since we're going to need to take the derivative, that's more easily written as 18,000 Q to the minus 1 plus 1,500 Q. So now we'll take the derivative. And negative 1 times 18,000 is negative 18,000. And then that's Q to the negative 1 minus 1 makes that Q to the negative 2 plus 1,500 Q. And you can change that to a rational expression for the first term if you want, but you'll get the same numerical answer regardless. So that could also be written as negative 18,000 over Q squared plus 1,500 Q. And with either expression, R prime of the requested value, the band being 30 units, turns out to be 1480. And I did double check my arithmetic, so I'm fairly certain that that is the correct number. So if you still have questions, please let me know, and I'll be glad to go over it with you again.